let's find the counterclockwise circulation and the outflux of the vector field F equals x minus y I plus 2x plus y j. So that's depicted here. But now we'll take a more interesting region enclosed by y equals x squared for x between 0 and 1, and y equals sine pi over 2x, again for x between 0 and 1. So these converge, or these meet at the point 1, 1, and also I guess at the point 0, 0, so these make a closed curve. So let me set up the integrals for both the circulation and the flux, and then evaluate them individually. So the circulation is the integral over c of x minus y dx plus 2x plus y dy. And using Green's theorem, that'll be equal to integral from 0 to 1. So x goes from 0 to 1. And then y will go from x squared, which is the bottom function, to sine pi x over 2. And then something in here that we'll fill in a second. Whereas the flux will be integral over c of now x minus y dy minus 2x plus y dx. And the integral will still be something from 0 to 1 dx, and from x squared to sine pi x over 2. Okay, so in the circulation example, we need to take d by dy of this and subtract it. So that'll give us a 1. And we also need to take d by dx of this. That'll give us 2 plus 1. So this is 3 times integral 0 to 1 of sine pi x over 2 minus x squared dx. And now that becomes 3 negative 2 over pi cos pi x over 2 minus 1/3 x cubed at 1 and at 0. So that's 3 cos pi over 2 is 0 minus 1/3. Then cos 0, so plus 2 over pi minus 0. So this is, this will be 6 over pi minus 1. Then the flux integral will take d by dx of this and d by dy of this, and then take a negative. So here we'll get 1 plus 1 dy dx, but that's the same integral as we got here, except with a 2 instead of a 3. So the flux will just be whatever this was times 2 over 3. So this will be 4 over pi minus 2 over 3. So again, the fact that the circulation here, so 6 over pi is at least 1, this is 0, so the circulation, the net circulation is counterclockwise, and 4 over pi is greater than 1, so minus 2 over 3 is still greater than 0, and so a fluid is, on average, the net flow is stuff is flowing out of this region.